Okay, come, let's start. Second last chapter, macromolecules. Now, Zayden, as I said, this will not be a separate chapter for you because it's incorporated under the alkanes and alkenes parts. But there are some concepts that you need to know. So first thing first, Jingqie, they need to copy down anything. Okay, now macromolecules. Zayden, what do you understand by the word macro?
Smaller.
Oh no, macro means big. Big. So you're talking about at least thousands of atoms and probably more than that. Hundreds of thousands. So first thing first, make sure you understand this means big molecules. But for you guys, you're not so interested in other big molecules, like for example, proteins. But you're not interested in proteins for chemistry. You're interested in one particular kind, polymers. Of course, there are others too, like DNA and so on, but don't worry too much about this too. You worry about polymers. Now, the common name for polymers is plastics. Okay, so basically, all plastics are polymers. Okay, but not all polymers are plastics. However, we won't go into that. But what the other word you need to know is made up of polymers are made up of small. Yes, you're right. Polymers are organic compounds. But importantly, how are they different from other organic compounds? They are made up of smaller units. Or I'll be even more specific. Smaller repeating units. It's like your primary school when they keep repeating the same pattern. Highlight the words repeating units. You can see these two words in your exam. Repeating units. Make sure you understand what it means. Of course, I'll give you some examples, but for now, bear with me. There's another name for this. Smaller repeating units, which you need to know the alternative name. They are called monomers. Meaning of mono? Yeah, good. Okay, mono means what? One unit or one repeating unit. So again, if you want to highlight monomers, you can see it in your exam. Make sure you know what it refers to. Okay, let's go a bit further. Not very simple. For you guys, there are only two types of polymers you need to know. Only two. Eight. Let me rephrase that. For you, only one type. For you, two types. Now, the first type is called addition polymers. Okay, for you, Zayden, you don't have to know the second type. And for you, Jingjie, the second type are called condensation polymers. So, of course, the word addition has a meaning. Quick revision. What kind of organic substances can undergo addition? Alkane,
Okay.
alkene, alkane, alkane. Okay, alkenes, correct. Yeah, I mean, Zayden, you're right. Alkenes, Xinjie, take note. So, in other words, basically, addition polymers means the monomer is an alkene. Keep that in mind. That's how you recognize addition polymers by looking at the monomer. So what happens is this monomer undergoes addition reactions. So take note, the name for this reaction is called polymerization. But it's also an addition. So it's called addition polymerization. So the key is this. Anytime you see this guy, the simplest, Kang Jingjie, can you remember what's the simplest alkene?
Which one?
Oh, what is it called? The structure looks like this. Zayden, can you remember name?
This is
2 carbons. So what's the prefix? E? Teen.
here.
Okay.
There's no meeting.
No, you cannot have a carbon-carbon double bond with a single carbon.
Oh, yeah.
Huh?
LP is double one.
Yes. So look out for double bond. So what happens is, this is the monomer. Okay. So, or this is the repeating unit. Remember, monomer also means the repeating unit. You keep on repeating this unit. And how many times do you repeat? Thousands, tens of thousands, hundreds of thousands, millions. So you get them side by side. You get many units side by side. As I said, thousands, millions, depending on how you run your polymerization. So you get them side by side. And then, what are the conditions for polymerization? Yes, I did. But it's okay if you forget. Now, polymerization typically undergoes or runs at high temperature. No need to know the temperature. High pressure. Okay, and typically you need a catalyst. No need to know the catalyst.
So polymerization can happen to any alkene.
Yeah. Provided you have high temperature, pressure, and catalyst. Okay. Of course, you must have the right temperature and pressure and the right catalyst. So, but I haven't told you what happens, right? Addition happens, correct? So what happens during addition is all the double bonds break. It becomes single bond. Okay, try not to miss this part. Double bond breaks, becomes single. Join. Join. And I want you guys to include an extending bond here. Do not just stop there. Make sure you have an extending bond on the left and right. Now, of course, it's not going to stop there. This is too short to be a polymer. It's going to be at least thousands of carbons long, at least. And you got to know the name. So this guy, the name is very simple. You add the word poly in front. So it's called polyethylene. Okay, so this is your plastic. And in case you're asking, oh, you better know this one. This one, I think they ask you occasionally. This is the one used for plastic bags, polyethylene. Okay, you see it every day, obviously. Next question. How many repeating units did I draw? 1, 2, 3, 4, 5, 6. Okay, so I have drawn 6 repeating units. Can tell, Zayden? Okay, cannot. So I won't draw it up. So 6 repeating units. Why is this important? Because your exam question may ask you to draw 2 repeating units, 3 repeating units. So you need to know how many to draw. Now, the other thing is, instead of writing or drawing this whole chart, I can write it as such. Okay, this one you better know too. Now, the monomer is this guy. 2 carbons. That's the monomer. So you have to show the monomer, and then you draw a square bracket or curve bracket, it doesn't matter. And then put 6 there.
Oh,
That is the representation of what I've drawn. Oh, forget I did not mention. In the exam, please don't forget your H, of course. I didn't draw the H. In the exam, draw the H. Yeah, it is. Now, one more thing. They can also, instead of writing out polyethylene, they can write this. So you better recognize if they show you this in the exam. Square brackets are still there. Oh, notice my bond here extends beyond the square bracket. That's the property. Yeah. Have to what?
Yeah, to
By right, if they are strict, they can still penalize you. So by right, you cannot draw like this. You cannot. Because this shows that it continues to the left and continues to the right.
Oh.
But anyway, I'm not done. In the exam, they may give you this. Notice my 6 has disappeared. Instead, they put an n there. Of course, n is a whole number. So recognize that this is polyethylene. They may not give you the name, but you have to recognize the structure. N is, of course, thousands, hundreds of thousands, millions. Okay? Now, the tricky thing is, this is easy. Ethene is easy. But what if they give you something like this? Let's say they tell you the monomer is propene. And you're supposed to remember the structure. This is propene. And then you polymerize it. High temperature, high pressure, catalyst. What is that reaction called? From monomer to polymer. Okay, good. But of course, you can add in addition polymerization. What's the name of the polymer after polymerization?
That's poly.
Yes, good. Just add the word poly in front and you get polypropene. Okay? Right. This is polypropene over the this one. This is polypropene. This one should be, I'm not so expert at it, but I think so.
How can you know in time?
Because when I bought it, they say polypropene. But how do you draw the structure of polypropene? I give you a hint. Okay, in fact, I give you a strong advice. Remember that if you can. Now, this is not very friendly. I withdraw it. I concentrate on double bond. It's the same, right? I hope you recognize. It's the same. Now, once I have something like this, you notice I'm focusing on the C double bonds. Once I have this, it's quite easy to visualize. So polypropene will have this structure. Don't forget your square brackets. Okay, let's draw a curve. I find it easier to draw a curve. Okay, this is polypropene. You must be able to tell. Didn't, okay. Now, of course, sometimes you can draw like that. I'll give you another shortcut. Okay, take note. We should recognize this is propene as well. Okay, can. Yes, once they polymerize, no more double bonds. They break, but they don't break totally. They break to become a single bond. No. Compare these two. Are they the same? This one versus this one. Not exactly right. So be careful. Okay, come, one more example. This, you know what is PVC? This polymer called PVC. Uh, that 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 covering, the white covering or white trunking, that one is PVC. Oh my God. For wire. Yes, for wire, but it also can be in for piping, water pipe. Go to your house. Do you have plastic pipes? You should have somewhere. Plastic pipes is PVC. So anyway, I'll show you the structure. So PVC is the polymer, by the way. I'll give you the name, but it's not the official name. It's called polyvinyl chloride. Yes, good. Yes. In other words, you should not burn it. It can become chlorinated compounds which are highly toxic. Highly toxic. So this is the polymer. What do you think the name of the monomer is? No brainer. Just vinyl chloride. Okay. So of course it undergoes addition polymerization. What happens is in exam, they'll give you the structure of PVC. This is PVC. I want you to draw the structure of the monomer. This is PVC, the polymer structure, because you see the N here. What is the structure of the monomer? I'm trying drawing, shouldn't be that difficult. So you have to work backwards, and it's quite common in the exam. How does the monomer look like structure-wise? Hmm? Yes, good. Monomer has a double bond. The polymer does not. But you still have to draw it out. My suggestion is concentrate on this guy. Concentrate on the repeating unit. Follow. That's all. Job done. I remove the brackets. I remove the N. I put a double bond here. Everything else look the same. Okay, so this vinyl chloride. See then? Okay. This will come out 100%. It will come out something like this. It will give you the polymer and it will give you this. And they ask you to draw this. But of course, they may teach you something a lot more complicated, like this. Now, imagine the exam, they give you this monomer, the single unit, it looks like this. No need to know the name. But actually, you should know the name already. Can monomer, the question asks you, draw the polymer. Or better still, let's make it more challenging. Draw the polymer showing 2 repeating units. How does your answer look like? Not trying. No one's trying. Looking.
Right.
Okay, Zayden, you two try to follow. Concentrate on this, where the double bond is. Redraw it. I mean, that's my suggestion. Now, if you have a better idea, go ahead. But otherwise, I think that this is very useful. Okay, redraw it. Yeah, I don't know whether recognize it's the same. Oh, agree, same. But let's make it even more compact. Because the more, I think, expanded it is, the harder it is to reproduce as a polymer. Let's make it more compact. No, reminder. I said this before, but I remind you now. C bond C. The bond is between C and C. So in other words, do not draw like this. Do not C bond to H. Just be very careful. Most likely you'll be penalized. So to make it even more compact, I represent this whole group into this chunk here. Now, once you have this, you're almost done already. It's now very simple. I just get this whole chunk, put here. Remember, 2 repeating units. I have a second chunk, put here.
The double bond, just
Good, double bond, connect here. This one connect there. But do not forget the left-hand side. We need to add in a single bond here. Yeah, 2 units, job done.
I think.
Yeah. Yeah, I zoom out. Come, good enough.
The other one, no.
Okay, that's good. Any questions, anyone? Okay, if not, I'll go to the next complicated part. Okay, for next part, Zayden, that one doesn't apply to you. So you can start doing this, the worksheet I've given you. So for you, Zayden, you can actually cross out this whole chunk here.
That's not.
Okay, and I think you can cross out some other chunks, but I can't tell. Like for example, say then you can cross out C, D, and E. Let me look at the MCQ as well. Okay, for MCQ, you can cross out number 4. Number 5. And number 6. Let's see. Okay, no, this one's still counted. Okay, yeah. Next part. This one. This one is tough. Come, add the notes, Jing. So basically, why do they call condensation polymers? Because they undergo condensation. But it's not what you think. This is not a change of state. It's different from the change of state condensation. All right, so what is meant by condensation? You got to know. It means a small molecule condenses out during the reaction. Now, in case you're asking what small molecule, water. I'll give you a few examples. Water is the most common one. The other common one is Higgs. Less common is HCl. Even less common, once in many years you see hydrogen cyanide. Yeah, highly poisonous. Highly.
Why is it?
Why is it here? Because they run this reaction in those closed vessels, so by right you're not exposed to it. Oh, but it smells like almonds. Hydrogen cyanide.
It's poisonous, how they know? It dies.
Well, if you smell it, you better run. You better run. Not run forward, but run the way you came from. Yeah. So yeah, just watch out if you ever smell almonds.
Oh.
Okay, but anyway, let's continue. But for you, there's one additional complication. There are 2 types. Two types. The first one is called polyester. Sounds familiar? Second type is called polyamide. Amide. Okay, very simple. Polyester example. Oh, you need to know this, unfortunately. This is a product. The trick name of the product, Herilin. Herilin. Maybe I'm right. More clearly. Unfortunately, you have to remember it.
Okay. Oh.
Which polyester is around, like all your this kind of shirt is polyester. Those dry fit. This one is not. This is a cotton shirt. Polyester is not around you, even your bags. That one is, can't see clearly. No, this is polyamide. The other one.
Oh,
But you have to remember this name. Oh, by the way, terylene is found in towels,
how?
bath towels.
What? How is like?
Oh, no, not towels. Now, for polyamide, the common product is, unfortunately, you have to remember this too, nylon. Maybe you've heard of this before. And yes, as I said, very commonly used in bags. Ropes. That's the easy part. No, the difficult part. What is the monomer? This is the difficult part.
House.
Yes, good. And
Oh. Alkene.
no, because alkene you undergo addition, not condensation. But unfortunately, two possibilities. This is the difficult part. You have a single monomer version and a double monomer version.
Yeah, to deduce.
Yes, yes. They'll give you the polymer and you need to deduce, is it a single or double? And if it's double, what are the two different monomers? This one is quite hard. It's quite hard. But I don't know. If you're really desperate, then you can skip this part. But yeah, it's going to definitely coming up. Okay, anyway, I'll make it easy for you. So if single, if you look like this, you have one chunk there. You'll draw a one chunk, like a rectangle usually. And then on this side, you see this. Looks familiar, right? On the other side, you see this. Looks familiar, right?
Resist.
Yeah, looks like resistor, but it's not a resistor.
Draw rectangle.
Yes, in the exam, they will show rectangle as well. So if they show rectangle, make sure to draw rectangle. You don't go and draw something else. Don't go and shade it unless they shade it.
What's it for?
Yes, follow. They can shade it though. Follow. Oh, by the way, just to give you a bit more context, what is this rectangle anyway? This rectangle is a series of carbon, like for example, 1, 2, 3, 4. It represents this. Or can be something else, can be anything else, but usually it represents something like this. So follow suit. If they give rectangle, if they give a triangle, you follow suit as triangle. Okay, but anyway, importantly, back to here. What are these two groups called? Yes, the other one, the right. Yes, just call it carboxylic acid group. This is called alcohol group. Can. So this is single monomer. Remember, one side alcohol, one side carboxylic acid. But they're going to come together, right? Correct? Okay, hold on. I think, let me redraw this to make it easier. Let me just redraw a bit. Otherwise, it's hard to see later on. So I will draw this. Okay, still the same, exactly the same. Okay, so I'm going to reproduce this guy, get them to join together. This is the fun part for me, not for you. So 1 unit, 2 unit. Let's play with 3 units for now. Okay, try to work closely. I'll get rid of this first. Now, what happens is this. Where are the bonds going to break? You need to know. No, here. This one you need to know. And here. And of course, here as well. Okay. Oh, Jingjian, hold on. I remember wrongly. I was thinking of something else. Oh, no. Redraw. The bonds you break here. Here. I was thinking of something else. Here. It's important you know exactly where, unfortunately. Okay. Now try to watch closely. So this guy comes up. This guy comes up. Right? What happened to them? Yes, and you get, yes, this is H2O. Do the same for the rest. Yeah, it is. Oh. And but make sure you know what's going on. Can what next? No, this bond cannot be just floating there. It must join to somebody else. Guess what? They join together. Can yeah, just draw two repeating units. But don't forget, lastly, there must be a bond jutting out. Don't leave this empty. Oh, of course. I didn't. I mean, I hope you can tell. We see this guy can always join to this guy here. Yeah. So 3 water molecules come up from 3 repeating units. Okay, can tell three units. So back here, how do I draw the polymer? No, this is the monomer, remember? So my polymer will look like this. This one is easy. Make sure you draw your rectangle. follow suit. Rectangle is rectangle. This is the tricky part. This okay one, I didn't. This is the tricky part. This is the correct answer. That is how you represent the polymer. Hey, can you see where? Because I broke off this part. Then I broke off this part. Take note, the bond between O and H is broken at the alcohol portion. Whereas here is between C and O at the carboxylic acid portion.
Oh.
Yes.
What is condensation?
Oh, that one is under which question? Number 2, MCQ. Oh, well, you should know that this is not condensation polymer, right? Yes. So 1 is of course wrong. Oh, yeah. Slater, any more questions? Finish.
I'm not sure on
Oh, okay. Okay, never mind. Then I give you the last page which I haven't printed for you. Something for you. No, Jingjian, just to let you know how students should draw a wrong version of this one. Okay, I show the wrong version, but try obviously don't remember that they will draw almost the same. Can you see what's different? So this is a common mistake. Just be careful. So where the oxygen is important. Okay, but let's go to the double version. It looks similar, except you have 2 different monomers, not one. So one of them look like this. You still have the carboxylic acid. Right. You have 2. Then I have another one. You notice they're like mirror images? And so
why is she?
because I want to indicate that these two are different. They are not the same interior. So now I have two, no? You know what's going to happen? They will line up together as well. Okay, make it easy for you. I only have this and this. Can they line up together? Okay, then you got to know where they're going to break. Huh? This one? Where does it break? No. This is the carboxylic acid group. It breaks here. This one? Yeah, at this part also, because this is the carboxylic acid group too. This one? No. This is the alcohol.
Oh,
It breaks in between. It breaks in between. Can So what next? This guy comes up. This guy comes up. This guy comes up. And of course you get water. This guy comes up. And you get two water molecules. Okay? So what happens? Well, this guy just join over here. Don't forget, draw a bond there. So, of course, that's not going to stop just at 2 units. It's going to continue joining. No? So you have a very, very long chain like this. But Jingjie, tell me how many repeating units are there? Two. Yeah, two only. Two, not four. Yeah. So if they ask you to draw two, this is what you should draw. Two pairs. Can, so this is a polyester. The double monomer version. Okay, can. Need to take photo.
yes. But take photo of what?
Not too sure exactly because they are all over the place. How about this? Possible to take?
Yes.
Okay.
So what's a polyamide?
Polyamide.
Yeah.
Okay, what question is that again?
Question 2.
Structural question. Oh yeah, I forgot to tell you. You can skip 2, 3, 5, and section C 1B.
1B.
One. One. No, sorry, you can't skip this one. Wrong. This one you retain. Let me double check. Yes, this one you skip. Yeah, only two.
Only 2, 3, and 1.
Yes, only 2, 3, and 5. No, this one you can't. This one you can't. This one you should be able to figure out. one important thing. How do I draw this polymer? I have two, right? Just now it was like that for the single version. Okay, for the double version, I have to. So for the double version, it looks like this. Notice one side has O, the other side doesn't. The side with the double bond O, there's no O here. And make sure you remember I have two different monomers, both are inside. Okay. This one is the carboxylic acid one, so make sure double bond O are here. This is the alcohol. Double alcohol, make sure the double O are there. Here and here. Okay, lastly, for this guy, I want you to recognize something here. Look at this. If I just show you this structure, what do you want to look for? To recognize that it's a polyester.
Rectangle.
No, well, rectangle can be anywhere. This one. What is this one? No more. It's something else. What is it now?
Ester.
Yes, good. This is the ester group. This one, you better know. There's a name for that. Actually, we mentioned it already. It's called ester. But in this case, it serves a special function. It links everything together. So we call it an ester linkage.
Oh.
And look out for that. Actually, you can find it here too.
What?
Here. You see?
Yeah.
How many are there? No, actually, there's only one full one. You need to have double bond O and the O.
Oh. Oh. Oh.
So once you see this, you can safely conclude this is a polyester. Okay. Oh, Jingjian, still fresh enough to continue?
No.
No, you need bubble tea.
What was?
Yeah, last one, polyamide.
How many?
It's similar to this.
2 times.
Yeah, 2 times. Actually, you can see the pattern, but maybe not immediately, but sooner or later you see the pattern. So 2 types. Jingjian, what are the 2 types? Which are?
Was house, yes, yeah, alcohol.
Okay, not in the sense. You have the single monomer type
Oh.
and the double monomer type. Unfortunately, you won't know which one will come up. They normally won't have both coming up. Only one type will come up. But I draw for you the difference first, and then you see whether you can see the pattern. A single monomer looks like this. Same thing, I can have a rectangle. Okay, usually they use rectangle, usually. But look carefully. Oh, looks familiar.
No ester.
No, something else. This is the unfamiliar part. Okay, this one, it's not strictly in your syllabus, but it's called the amine group. Now, look at the double monomer. It looks similar. Now you see your double carboxylic acid again. And then here, You have your double amine. Okay, yeah. So same thing. These two guys will join together. This guy will join to itself.
Oh.
But the interesting part, how does it join now? There's no longer alcohol now.
Breaks.
Yeah, but of course you don't know where it breaks, huh? Okay, let me redraw this one. Okay, hold on, I just redraw this one first. Yeah, go ahead. Same thing, Jingxie, where does it break? Here.
Oh.
This is carboxylic acid, so it breaks between C and O. C and O. This one, where does it break? Here. N and H.
What is that?
Nothing, I just a covalent bond between N and H.
And all water.
Yes, good. It forms water. So this guy comes up. This guy comes up. Water.
The water drinkable.
It's mixed together with all other toxic products and reactants, so it's not easy to extract. Yeah, no point extracting.
Is there a way to make?
No, the water is not a lot. It's very little.
Any ways make water.
Yeah, and you burn hydrogen
So why are people not doing that?
because it's too expensive. Where do you get hydrogen? Hydrogen comes from water again.
Oh,
Come, Jingxie, I hope you know what's going to happen next.
right.
Yes. Too easy. But I want you to recognize this. Try. This is a very characteristic pattern. OCNH. There's a name for it.
Oh.
This is called amide linkage. That is why they call this a polyamide. So look for this OCNH in this order. O is double bond. If you see this, you are looking at polyamide.
Oh.
Need to take photo?
Of course.
Mm. But in the polymer structure, you may not see this. You have to infer that it's there because it's going to look like this now. Yeah.
Please.
Okay, come. It's going to look like this. So this guy is gone. This guy is there. And H is still there. So this is how the structure is drawn for a polymer. Remember, square brackets and N. It keep on repeating this unit. Now can you still see OCNH? No.
Also, yeah.
Yes, you have to infer. You have to deduce that the next unit, when they join it in, you can see OCNH.
Yes, no.
What's his name?
On.
Dupont.
Ah.
I can't remember the guy's name, but Dupont is the company's name. Yeah, the company came up with this this reaction.
Oh shit. What is even this used for?
Oh, nylon, your bags, it's used to make that kind of material. It's everywhere. Last one, double monomer. Same thing, put them side by side. Okay, by now, you better know where you break. Here. Yeah, where? Yes, the whole OH come up. Remember that. Well, now let me just redraw this one first. Okay, because this is the carboxylic acid group. Okay, so OH comes up. OH comes out. Here, where does it break? Between what and what? Good. No need. No need, but it's easier to visualize the way I do it. So same thing, this whole chunk comes out. Oops. If this guy comes out, and same thing, you join the leftover. How many repeating unit is this? One. Because you need to repeat this entire chunk. Oh, because this chunk and this chunk are different. Don't forget, put the square brackets. At the end. What else do you recognize? At your A-mic linkage. Anytime you see this polymer is a polyamide. Okay, I make it as simple as possible already. Last chance, you need to take any photos? Okay, done. Do your work. Every question. Yeah, any question?
How is it false? So,
That one is linked to another chapter. Is what? Yes, it is. Can you remember what kind of substances can conduct electricity when they have what? Electrons, huh? But does it have delocalized electrons? No. What's the second condition? Or okay, second possibility to conduct electricity? Yeah, you heard that ionic compounds because they have free Oh, okay, I won't say free. They have mobile ions. So did they say ionic compound? Then what compound is it? It's a giant covalent structure.
Oh, yes. Yeah.
Inflection.
Oh, my reflection.
Oh, okay. What about it?
Why?
Why do you have your reflection? Where?
Of the view.
On the way. Oh, this one's for people for learning English. You need to write your reflection. Hey, Jing, I mean Zayden as well. What's the structure of polymers? They are giant covalent structure. Okay, take note. Because they have covalent bonds unless it's a special polymer, which may come up for you. Like this
Wow.
one.
With this special.
This one is not. This one is not. But this one is.
Oh.
This one is. Hmm. Anyway, Zayden, just to answer your question now, do you think it conducts electricity? No way. It doesn't have mobile ions. It doesn't have the localized electrons. Only covalent bonds. Monomers join together without. Let's ask Zayden. Zayden, do you have the answer for this one?
No.
Oh, nothing.
No.
Well, basically, remember addition means two reactants join to give one product. Only one product. So in other words, you don't lose anything. Jing Jing.
Then another one loose and
Yes, with the you can put loss or removal.
On top, over here for macromolecules.
This one.
Yeah.
What molecules made out of many what molecules?
Big molecule.
Yep. Yep. Big and small. Yeah, make sure you know this too. Macromolecules are large or big molecules made out of many small molecules. Zayden, do you have an answer for this one?
Polymer.
Yep. Okay, one type of macromolecules is polymers.
Linked together by many small weakly units called monomers.
Yes, good. Make sure you know that word, monomers.
Wait, then plastics produced by polymerization are known.
Sorry, which one?
Below
This one.
No, below the. Yeah.
Plastics produced by polymerization are non. Yes, good. Oh, that one can still come up for you. So make sure you know this one.
It's Teflon.
Teflon. It's a plastic. Where is it? Teflon. D. Oh, okay. Teflon. Wow, this one very specialized. But I haven't seen it coming up for a long time. Okay, I'll show you Teflon.
No.
Yeah. And then you judge for yourself. Come, I show you what is Teflon. This is Teflon. Oh, Zayden, this may come up for you. Teflon looks like this. It's a plastic, obviously. You draw the structure there. What do you think? Is this a condensation or addition polymer? But of course, Zayden, for you, there's no choice. It's definitely addition. Make sure you can tell this addition polymer. How to tell? Do you see Esther?
No.
Do you see AMAC? No, what do you see? Just two carbons, right? So it must be an addition polymer.
Oh. Bury plastics.
Do you bury plastics? You either burn it or bury it.
When we bury it, nothing will happen.
Nothing. It will stay there for thousands and thousands of years.
What the fuck? When you burn it, you produce ash.
Yeah, which you still have to bury, but you reduce the volume.
Oh.
But you give out toxic gases, don't forget.
Then how Macromolecules how they burn? They're not Macromolecules. How they burn?
They burn in an incineration plant. Jurong has 3. There's one more. Where's the other one? Incineration plant. I can't remember. They burn in the incineration plants, and then the ashes they send to Macromolecules.
Oh.
But you have to control the toxic gases when you burn it.
What purify?
What do you think?
I don't know.
Because like PVC, that kind you burn it, there's chlorine inside, no? So what happens when you burn chlorine? Don't know, right?
You get chlorine. Get no chlorine.
You some chlorine gas, possible, but it's not exactly stable. You tend to remember chlorine is an oxidizing agent, so it tends to oxidize something else, like plastics. It can do that, but it can also oxidize with, let's say, water. Then you get HCl.
Oh wow.
So your toxic gases include HCl. It's quite easy to capture HCl, no? How? Your factory is producing HCl gas. How do you want to remove HCl? It's so significant about HCl. It is. HCl. How do you remove HCl from the air?
You catch it.
With what? There's something you should know along HCl is what? HCl is an acidic gas, right?
Oh, so you neutralize it.
Yeah, you captured it using sodium hydroxide.
Shit.
I think it's come up before, many years back. And keep that in mind. And of course, you should know how to write the equation too.
Aye.
So keep in mind, any acidic gases can be captured by alkaline, like lime water. In fact, that's what they do in real industry.
So, going to produce energy.
Yeah, of course, yes. They sell the energy. That means it depends on the power you produce. Your voltage and current. How much are you producing?
That's is powerful.
They scheduled it to last until 2050.
So when you reach 2050, they're going to build another.
Yeah, that's what they say. That's why I asked them. They said they'll probably look for another island. But no announcements yet. I think it's still quite secret at this point.
Still very long.
Yeah. Let's hope so. At first, the island was supposed to last until 2030, when they first opened up the island. 2030, which is soon, right? Yeah, but after that, they revised the deadline, the schedule, because they want more recycling to be done. So because of the increase in recycling, they expect the landfill to last until 2050.
Recycling the life of.
Yeah, because you bury less stuff, you recycle metals, plastics even.
The problem is I don't see anyone recycling.
Not as an individual, but on industrial scale, yes. Like all the metal industry.
Okay.
Not easy, recycle. Not easy. It's quite expensive to recycle. Like plastics. Singapore doesn't recycle PVC, that kind. Singapore doesn't recycle that. You only recycle the simple plastic like polyethylene plastic bags, PET, which is your Coca-Cola bottle.
But what if they recycle the PVC, chlorine gas will come out?
It's the big problem. So far, what they do is they send to China for recycling. China can recycle anything. But yeah, right. The chlorine gas is a big problem.
So that's why they don't want to do it.
Yeah. It's not safe, I would say. It's not easy to recycle things. Even metals are not easy. I mean, like the computer circuit board, there are quite a lot of metals inside, copper especially, because they use for the wiring. But how to recycle it? Yeah, how? It's all jumbled together with your plastics. How to separate the metals from the plastics? Not easy. You want to melt the whole thing, but you have a problem, no? You heat up the plastic will emit toxic gases too.
Also, what they do with those cables? So this is in China.
Yeah, wow. Manually get those foreign workers to pull out. Okay, the other way. There's actually one way that maybe you all have thought of. How to get the metals out? No, non-magnetic. Copper is non-magnetic, you should know that. They actually dissolve in acid. And then they separate the metal salt out. And then, like separation process, and then you separate the metals from the salt. That one is not easy. But don't forget, the plastics also dissolve into the acid. So you have to separate the metals from the dissolved plastics and stuff like that. It's not easy. But that's the standard practice. They don't melt it. Melt it is too dangerous. So they dissolve in acid, all the circuit boards, in very strong concentrated acid. And then you still have to extract the metal salt, and then from the metal salt, you can extract the metal. It's expensive, it's not cheap, right? So there are very few companies doing this in Singapore. Singapore is very expensive to do all these things. So that's the reality for you. It's not cheap to be green.
No, I'm good.
It's not cheap at all. Okay, guys, any more questions for today? If not, bring this back next week, then we'll work through it.
I'll bring over.
Okay. Actually, you should brought today. Should have brought today, but never mind, tomorrow is fine.
No, I thought we was watching them.
Yeah, I know.